And over the next 30 minutes, I'm going to provide a high-level overview of the application of AI within manufacturing. Kieran, my colleague from the AMRC, will then go into more detail about particular use cases during the next presentation. So what am I going to cover? So the topics I'm going to cover today are the importance of manufacturing to the UK and the opportunities afforded to the sector through the application of digital technologies. I would then talk about how the UK is promoting the innovation and adoption of these industrial digital technologies, and then introduce you to where we're seeing AI within manufacturing, and then finally take you through a broad selection of use cases. So firstly, why is manufacturing important to the UK? So when you ask people where the UK ranks in terms of manufacturing, the typical response you get is maybe sort of the 50th or 60th in the world, and they see the UK as a service-based economy, when in reality we are the 9th, and we've been 8th and 9th and 10th for the last sort of 10 years. And the largest sectors being food and drink and transportation, such as cars and aerospace. So these two account for 30% of our output. And there's actually over 111,000 manufacturing companies within the UK. So here in the Northwest, manufacturing is very important to the economy. It's the largest manufacturing region, employing 345,000 jobs, and it accounts for 9% of the economy. But you can see on this slide the broader impact of manufacturing within the UK. The sector accounts for 192 billion of economic output. That's 10% of the UK output, which is similar to that of France and the US, whereas countries such as Germany and South Korea, you probably get up to about 30% of the economy based on manufacturing. There's directly 2.7 million people employed in the manufacturing sector, and it creates high value jobs. So the salaries tend to be above average and 13% above the rest of the economy. It accounts for 66% of R&D and 15% of total business investment, and 44% of our global exports, worth about £273 billion. And finally, manufacturing is a source of productivity. So manufacturing is on average 12% higher than the average across the rest of the economy. So I wanted to talk now about digital and its application within manufacturing. And many of you have probably heard of the topic of the fourth industrial revolution. So manufacturing, as in all sectors of the economy, have been transformed in the last 10 years more than 10 years, by digital technologies. The application of digital to manufacturing was christened in Germany as Industry 4, and this has now been termed the fourth revolution. So what do we mean by a revolution? So that is the definition being a significant change in technology that drives a huge change in industrial processes, output, and productivity. So the first industrial revolution was driven by steam, the second by electricity, and the third by electronics and IT. And the fourth, we're now is saying, is being driven by digital technology. But what distinguishes this revolution from its predecessors is the speed of technology breakthroughs, which has no historical precedent. So when compared with previous industrial revolutions, this one is evolving at an exponential rate rather than a linear pace. The other factor to consider is that the duration between these revolutions is getting less and less, and there are already commentators declaring that the end of digital era is nigh, as defined by mobile, social, and cloud technologies, and the 2020s will see the fusion era based on powered by cognitive, immersive, and trust technologies. So the application of digital technologies to manufacturing has enabled the creation of what's called smart factories, which are realizing significant improvements in operational performance. So those of you who are interested in understanding more about smart factories, the World Economic Forum have identified 54 lighthouse factories which are exemplars in the application of digital technologies. So you should be able to Google that and see what these factories are and what sort of activities and technologies they use. But based on work undertaken by Accenture, the benefits are significant, as you can see on this chart, anything between 20 and 40% across all KPIs, whether it be efficiency, flexibility, or quality. I think of key importance is the contribution to net zero. This is an area that's going to continue get increasing attention as digital technologies can significantly reduce greenhouse gas emissions through better monitoring and efficient use of resources. So going forward, we expect even greater benefits as we move from smart factories to the emergence of intelligent factories. So this chart shows the emergence of technologies and the particular bow waves or waves of technology as they go through the economy. One key emerging technology over the last few years has been AI. You can see AI was about in the 1950s, but the rise of AI and the exponential rise of AI has only been recent. This is due to the availability of compute, cloud, commercial pay-as-you-go cloud-based solutions from companies such as Oracle, IBM, Microsoft, Google, which all reduce the barriers to entry. I think the key point here is that although you've got significant breakthroughs introduced by AI or robotics or IoT, what really turbocharges the impact within industries when you see them working in concert together. So what's the UK's response? What are we doing in the UK about encouraging the adoption of these technologies? The UK, like all developed economies, have government intervention in this area. So in Germany, for many years, it's been Industry 4, in France, Industry the Future. And in the UK, we have something called Made Smarter. Made Smarter is about developing and promoting digital technologies. And it's a national program it's a joint collaboration between industry and government with an ambitious target on trying to make the UK a global leader in industrial digitalisation by 2030. And the programme is built on 4 strategic pillars. The first pillar being leadership. There's a national commission providing strategic direction, promoting awareness, and raising the visibility of the UK brand. Within that collaboration, there's industrial contribution from Rolls-Royce, BAE Systems, JLR, GSK, Airbus, Accenture, a number of SMEs and trade bodies such as the CBI, Make UK, and the TUC. So this is all about trying to indicate UK is interested and actively promoting digital technologies within its manufacturing base. The second pillar is innovation. So last year there was 147 secured from the Treasury for government investment. This has been matched by industry, and in total there's a £363 million innovation programme targeted at developing the next generation digital technologies. The third pillar is adoption. So although we're pushing the boundaries in innovation, we have a large number of companies which need to be brought on stream and starting to adopt these technologies. There's a whole series of barriers of why these aren't being adopted by the smaller companies. So in the Northwest, there's a £20 million programme underway to support the adoption of more mature technologies within SMEs, with a target increase in GVA of over 100 million, of which 34 million has been identified in the projects let to date. There's also a submission within the current comprehensive spending review under consideration with UK Treasury to scale the projects out across the other regions of the UK. And finally, one of the most important areas is skills, and this is always cited as one of the key barriers to adoption. There's a piece of strategic work led by Ingenuity, and they developed an online training material for workers looking to upskill into digital, with training material provided by industrial partners such as Rolls-Royce. So where are we seeing AI applied in industry? So Accenture recently undertook a global survey of the application of industrial technologies across industries of 600 companies across US, Europe, and Asia, covering 8 industrial sectors. There's 53 use cases identified, covering design, asset utilization and efficiency, worker wellbeing and efficiency, planning, supply chains, and collaboration. So the purpose of this slide is not to go into any detail, and I'll cover a number of use cases later. But based on those use cases highlighted in purple, you can see how AI is starting to feature more in the use cases across industry, albeit in the early stages of the life cycle, predominantly in pilots. So next, I just wanted to give you a flavour of where the top use cases are being seen in industry. So these are the top 10. You can see quite a broad range of techniques and technologies covering all aspects of manufacturing, so not just shop floor production, whether it be physical security, cyber, resources, automated data. But what you can see is the top 3, predictive maintenance, quality inspection and assurance, manufacturing process optimization, covers 60% of the use cases we typically see, with quite a rapid emerging application within supply chain. So I was then going to now just dive into quite a broad range of use cases, but just at a very high level to give you a flavour of the breadth of these use cases across the manufacturing sector. So first, in design, we're seeing AI applied through generic design, especially linked to additive manufacturing due to its ability to create a wide range of product designs. So fundamentally, generative design allows the full design space to be explored based on constraints input by the designer, whether it be material type, required strength, weight, manufacturing processes, or cost into the AI algorithm. The benefit of this technique is it allows all design options to be explored, significantly more than can be explored in a manual process, and there's no bias from the human designer in the definition of those designs. So in this example here, it's a GM seat fitting, and it's been redesigned within using a generative design tool. In the center, you can see a range of some of the options that were explored by the software. And on the right-hand side, you can see the previous version, a multi-component version of the fitting. And post-generative design, you've got one point part, which is 40% lighter and 20% stronger. So as I stated before, AI in supply chains is a growing topic. And we recently found in a survey of executives that 86% of executives believe platforms will be used to share assets and create an ecosystem. 90% believe the workforce will need to be transformed by automating repetitive tasks. 94% are planning to invest in visibility and collaboration over the next 5 years. 95% believe big data, computing, artificial intelligence, and the Internet of Things can enable real-time supply chain operations. And 92% think supply chains can seamlessly work and interact with humans. So as mentioned before, supply chains are ripe for disruption with the introduction of both digital and AI technologies. So a particular example here within the supply chain, this is on demand planning. So Accenture have developed this AI robot called Pepper, and it's used as a planning aid. So it's trained to verbally interact with humans, and through natural language processing, users can review forecast performance, identify data and forecast issues, prescribing and executing user-approved actions. So think of interacting with Alexa to request, explore, and action supply chain decisions, with Alexa having full access to your business data stored across multiple systems. Other use cases, typical use cases around quality. This is probably one of the most used ones in terms of quality inspection. So AI coupled with vision systems to identify manufacturing defects. So on the example on the left is a circuit board manufacturer where Jabil is working with Microsoft using AI to improve identification of defects real time as a circuit board progresses down the manufacturing line. It previously relied on human inspectors who had only a few seconds to decide whether there were any defects. AI-based visual inspection based on image recognition increases defect detection rates by up to 90%, compares with human inspection and an unmatched throughput rate. On the right-hand side is another example with work undertaken by AI labs based in Bristol, working with Airbus to identify which supplier provided parts were creating additional work on the assembly line due to variations in tolerance. So through the inspection of parts, they were able to analyze trends in the parts, tolerances being supplied to the line, and highlighting these to the suppliers who could then adjust the manufacturing processes, with the result of the time to assemble being significantly reduced. The purpose of this slide really is just to give you a flavour of some of the other use cases and the breadth of these use cases. So if we take the first one, Accenture has worked with Ducati, and this was actually taking data from the bike in the field. So using AI and IoT to find a faster and simpler way to pinpoint the perfect bike configuration for each race. So with advanced learning applied to real-time data captured from up to 100 sensors on each bike, engineers were able to optimize race performance with unprecedented speed and accuracy. Another use case is actually in supporting project planners. So again, trying to give a bit more breadth in terms of what we mean by manufacturing and the use of AI. So in this example, we worked with a company using machine learning to predict engineering project schedule overruns and empower engineers to better manage their products. A user-friendly tool was created using machine learning models to provide activity schedule predictions, which were 50% more accurate than the scheduler's estimates. So these models used a combination of historical data, real-time weather data, and market data to provide a more accurate duration than the schedulers were predicting themselves. Mentioned before, the most common use is predictive maintenance. So unplanned downtime on machinery costs manufacturers an estimated 50 billion annually and causes 42% loss of productive capacity. In this use case, AI is being used to predict the failure of an asset. The software uses sensors data available from the large assets to create digital representation of the current state of the asset, and uses advanced data modeling and analytics to indicate the future state, so a sort of digital twin. This enables a maintenance engineer to schedule appropriate maintenance to reduce the amount of downtime and reduce it prior to failure. Another example is with Toyota in a plant in Sweden, which is using AI-driven trolleys filled with baskets of tools and parts and components. The AI trolleys are moved around the factory, knowing exactly where they are, what they are carrying, and which workstation requires the delivery of goods. The onboard AI enables them to navigate around the factory and avoid obstacles and collisions. And the last one is health and safety within the factory. This includes vision systems to identify potential hazards on the shop floor and oil spillage. A more typical use case is in a company in India, which used AI to help manage COVID risks through exploitation of real-time video analytics to provide alerts if workers were not wearing safety gear or breaking social distancing guidelines. They also I explored the use of thermal cameras to display body temperatures in different colours, with orange and red indicating the higher than average temperatures to trigger an alert when the person is potentially running a fever. So finally, and in summary, I hope I've been able to increase your awareness of how AI is and will continue to transform manufacturing. AI in manufacturing is part of a larger trend towards fully automated production, transforming smart factories to intelligent factories. This is redefining the way the companies are running their production lines, enabling greater efficiency and human capabilities, providing real-time insights and facilitating design and production innovation. Thank you very much.